We are going to practice some more with piecewise functions. I know they were giving you guys a little bit of a hard time. So I'm going to practice graphing on this section. The way that we do this is I look at this first equation and it says x plus 5, f of x equals x plus 5. So I'm going to graph that. The y-intercept is 5, 1, 2, 3, 4, 5. And the slope, which is right here, is 1. So I know that this line looks like this. I'm going to do it really lightly. Okay, and when is this important? When x is less than -2. So here's where x is -2. And so I only care about this line on this side because this is where x is less than -2. So I'm going to erase this part. All right, so let's recap. What did we do? We just drew this line, and then we said we only care about that where x is less than -2. So it's almost like I slid something. I don't care, I don't care, I don't care, I don't care, I don't care. Oops, I start caring right here because that's where x is -2, and all of this is less than -2. All right? Now, it does not have equal sign, so I'm going to have an open circle right here. Now I'm going to graph this one. The y-intercept is -1. The slope is -2. And that is happening right here. So, and it's a closed circle. So if you have an open circle that intersects with a closed circle, it's just a closed circle. Okay? Now we're going to answer these questions. Is it a function? Does it pass the vertical line test? Yes, it does. So it is a function. And let's find f of 3. F of 3 is -1, 2, 3, 4, 5, 6, 7. F of -4, 1, 2, 3, 4. Go up and down this line until I intersect with this line right here at 1. F of -2 is 3. Okay? All right. Let's look at this one down here just to give us more practice. So once again, I'm going to graph this line. The y-intercept is 1, sorry. The slope is 2. And I only care about this line where x is greater than or equal to 1. So if I had this line right here, I'm going to end up erasing some of this because I only care about this where x is greater than 1. So right here, x is 1, and on this side of it, x is greater than 1. So I don't care about this picture until right here, and it's a closed circle. Okay, now I do the other part. The y-intercept is -3. The slope is 1, rise over run 2. Okay, I only care about this where x is less than 1. So right here is where x is 1. I care about it on this side. I would have an open circle here. Sorry, it's not exactly too straight. So how do I know when to have an open circle? Because this doesn't have a line underneath it, it's an open circle. That one has a line underneath it, so it's closed. All right, f of -2. So I go to -2. Look up and down until I cross another line right here. So that's -4. 6. 1, 2, 3, 4, 5, 6. So I'd have to go up until it crosses this line. Well, let's see. We're doing rise 2, run 1, rise 2, run 1, rise 2, run 1, rise 2, run 1. Oh my goodness, this is confusing. So what I can do, if I don't feel like trying to figure it out here, what I can do is plug it into one of these equations. Well, 6 is bigger than 1, so I'm going to plug it into here. So 6 times 2 is 12, plus 1 is 13. All right. F of 1, 1. So I have 2 dots here. I'm going to use that one right there because that's colored in. It's a 3. All right, now I don't want to do every single sheet of this packet. I just wanted to show you some of the different ones. So I know I'm jumping to number 7. What we're going to do in this, we're just going to do a few of them. What I want to do here is show you how would we write this equation. Okay, you can see there's 2 parts. This part here, and then it changes right here, and I can tell because the slope is slightly different. So it doesn't matter which one I write first. Let's just pick one. hold my paper straight. Maybe let's look at this part. Okay, so the y-intercept is 0. So I'm going to say f of x equals, and the y-intercept is 0, and the slope looks like it is a positive 1. Rise 1, run 1, run 1. Okay, so I have f of x equals x, and that is if x is less than, because it's at that line, it doesn't really matter which one I have an equal sign, 0. So at 0, I care about the part, that rule goes for where it's less, the x is less than 0. So then this part is where x is greater than, only one of them I'm going to put an equal sign to. And what's this equation? The y-intercept is 0, but the slope of this guy is 2. All right. Let's try to do this one over here. Oops. Okay, so you can see there's 2 parts. So on this one, remember, to write the equation, I need the slope and the y-intercept. So I'm going to say, f of x. Let's just do this one first. It doesn't matter. It looks like right here. So I'm going to say the y-intercept is 5. My slope is 1, so I didn't need that much room. And I care about that. It's on this side, so it's going to be when x is less than, not equal to, because that is not colored in. I know I drew on it and made it look colored in. That one is colored in. -2. Okay, because -2 right here is my dividing line. So this picture is where it's less than -2. So the other one is where it's greater than or equal to -2. And now it's going straight across like this. It's going through the y. So that's where y equals -2. And if I forget, I can say to myself, okay, well, this coordinate here is 0, -2. This is 1, -2, 2, -2. I notice that I keep saying -2, -2, -2 for the y's, okay? All right, let's do, I wanted to do one where we had to make it, okay? See my beautiful table? All right. The admission rates at an amusement park are as follows. Children 5 years old and under are free. Children between 5 years and 12 years inclusive. Inclusive means it's including the 12-year-old, or the day they turn 12, I guess, is $10. Children between 12 and 18, 25, and adults are 35. Write the piecewise function that gives the admission price for each. Okay? So we have f of x. Let's just do one at a time. Okay, well, what's the first price? The first price is I pay nothing, 0. And when do I do that? If x are 5 years old and under, okay? So if it's less than or equal to 5. All right, let's look at the next section. I'm going to pay $10 if x is in between 5 and 12. Now, if I am 5 years old, I would be free. I guess if I'm 5 years and 1 day, then I would have to pay $10. But if I'm 12, I pay $10 because it said including, it's inclusive of the 12. All right, the next price I have to pay is $25. And when do I do that? Well, the 12 was already included in this one. And this says it's including for 18. And the last price is $35. And that's for adults. So I guess it is for 18 or O if X is greater than 18. Okay? Now let's graph it. So my first is this, we're going to say that this is the age here. And this is the price. All right, so I pay 0 for the first 5 years. And that's including here. So I'm going to put a closed circle here. Kind of hard to see on the bottom there. Then it jumps to 10. And 10, I pay 10 when I'm between 5 and 12. Okay, so let's see. This one needs to be a closed circle. So if I'm 6 years old, I pay $10. 7 years old, I pay $10. 8, 9, 10, $10, $10, $10, 12, I pay $10. Okay, then it jumps at 12, now I pay 25. And that is until I'm 18. And it's including 18. And then at 18, it jumps to 25. I'm sorry. At 18, it jumps to 35. Open circle, and now it's just going to be an arrow. All right. And this does pass the vertical line test, so because no matter where I stop, it's only going through the line in one place. Even here, that one is not, that's an open circle, and that one's a closed circle, so it's going through the line here, okay? All right, I wanted to show you, I just feel like sometimes we need examples of these word problems, because we can't think of them too easily. All right, you have a job where you make $10 an hour. After you've worked 40 hours, you get paid time and 1/2. This happens a lot, quite actually. You may only work a maximum of 60 hours. Write a piecewise function to represent your pay up to 60 hours. Okay, so we have f of x equals, and in my head I'm going, oh, it seems like a lot of work. Okay, you have a job where you get paid $10 an hour. So that one's easy, 10x. I always think the first one's the easiest one to get. And when do I get paid this? When the hours, when x is in between 0 and 40. After you work 40, so 40 is including here. So after you work 40 hours, you get paid time and 1/2. Okay, so I got to think about this for a second. If I make and sometimes I'll write down this little chart on the side. So if I get 40 hours, how much would I make if I worked for 40 hours? So 40 times 10 is 400. And then at 41 hours, I get time and 1/2. Well, what's time and 1/2? If I get paid $10 an hour, and then I get paid time and 1/2, well, 1/2 of 10 is 5. So that means for every hour over 40, I'm getting paid $15 because it's time and 1/2, okay? So I know right now my slope is going to be 15x because now it's increasing time and 1/2. So at 41 hour, I would get 415, right? And then at 42 hours, I would get 430. So sometimes I like writing this out just so that if I go wrong, I can double check myself here. Okay, so I know the slope is going to be this, but I have to subtract the first 40 hours of work because I'm only getting this 15 after I do that, okay? So I'm going to have to subtract the first 40 hours. So let me show you what I mean. If I worked for 40 hours, I would subtract the 40 hours and I wouldn't be getting this $15 extra at all. But if I worked for 41 hours, I'm only getting one set of $15 extra, okay? But I still have the $400 that I got paid. So I have to plus the $400. Now this seems a little shaky, so let's see if we're right. We know these are the right answers. 42. If I said 42 minus 40, 42 minus 40 is 2. 2 times 15 is 30. 30 plus 400 is 430. Okay, looks like we're in good shape. Now, when can I use this? It's not just endless time because it said the most I can work is 60 hours. So I know it's between 40, 60, and now let's figure out what I do with these signs. I can work up to 60 hours, so I'm going to underline that. Well, if I work exactly 40 hours, then I'm still getting only paid $10 an hour. Okay? So that looks like our equation. Now we're going to graph it. At this first part, it says the slope, my y-intercept is 0, and my slope is 10. So, okay, remember, this is going up 10 over 1. Notice these are going up. So if I went up 5, it looks like this is going to be my slope. So how can I explain that? Rise over run. So I'm rising 10 and I'm running 1. So here, if I rise 50 and run 5, that's the same thing as 10 over 1, okay? So this is, and I only care about this until I get to 40. So I have this going on here until I get to 40. So I'm gonna put my hand here because I know this is gonna stay consistent. Oh, sorry. And here's 40, and it's gonna be a closed circle on 40. And then what happens at 40? Now I have this equation. Well, this equation seems quite complicated. This equation seems quite complicated. Like I'm not sure what the y-intercept, I'm getting a little bogged down here. So I'm gonna distribute this 15. So I have 15x minus 15 times 40. Oh, 15, 30, so 600. Plus 400. So I have 15x minus 200. Okay, so the y-intercept is negative 200. Oh my goodness, that's all the way down here. So what I want to do is I'm going to plug in a 40 because I'm going to see what happens here. I can't deal with plugging my y-intercept. Normally I would say, let me sketch there, and then I only care about it, but this seems tricky. So at 40, let's plug it in. 40 times 15 was 600. 600 minus 200 is right here. Okay, so let's just see what the next number is. Let's see if I plug in 50. 50 might be easy. 50 times 15, 15, 30, 60, 75. So I have 750. 750 minus 200 is going to get me 550. So at 50, my answer should be 550 here. Okay, so now my slope is 3 over 2. So keep going with that. 3 over 2. So ever so different of a change, right? It is slightly steeper. Yeah, 3 over 2, 3 over 2. Okay. And now that I think about this, we probably should have written this instead of this. Like that's kind of our work. And then we should have put this up here. All right, I'm sorry about that. And then this would have to stop at 60. So let's make sure we do that. Stops at 60 because I can only work 60 hours in the week. All right, trying to go through this, I know. At least you don't have to copy down notes today. All right. Like I said, we're just going to do 1 or 2 of these problems. So here I'm looking for f of 2, and I'm going to use my function here. So 2 is greater than 0, so that means my output is 2. Let's do g of 7. I'm going to look over here. So 7 is greater than 3, so 7 times 2 is 14, minus 1 is 13. These seem pretty easy for you guys. H of negative 4. So negative 4 is less than negative 2. A half of negative 4 is negative 2. Negative 2 minus 4 is negative 6. I feel like I need to double check that real quick. Negative 4, negative 2. Yes. Okay. Now we're going to do a few from one more page here because I wanted to show you how I could work either way. Okay, so if I look here and I'm trying to come up with the equations, right? I'm trying to see which one works. So if you look here, oh, I did not like this. This is going by, like that's 1, 2, 3, 4. So I notice that all this stuff changes at 1. Okay, so in other words, I'm using this equation until I get to 1, and then I'm changing over to this equation. So I'm looking for which one has the domain where it changes at 1. Okay, well, just because I know that, I'm able to say, well, it could be this answer, it could be this answer, or it could be this answer. I can rule out 3 of my options with only looking at where it changes from one equation to the next. Okay, so I notice this has a horizontal line. So I'm going to say, well, what number is that at? Well, 1, 2, 3, 4, 5. So negative 5. So where y is negative 5, and it looks like it's right here. So this one matches A. All right, so I kind of started here and went backwards. You could also go the other way. You could say, okay, let's find this one. Well, this has a y-intercept of 4. Now, I only care about this at the 0. So which has a y-intercept of 4. Looks like right here. That's the only one. So y-intercept, where was it? Y-intercept of 4, a slope of 1. Yes, because remember this is rise over, nope. Is there another one with a y-intercept of 4? Let's see this, y-intercept of 3. Match the piecewise functions with the graph. State below each problem you've picked for the graph. Okay, so let's find a y-intercept of 3 and a slope of 2. Here we go, look, it's right here. Silly me. Okay, so this one has a y-intercept of 3. So if I'm looking here, y-intercept of 3, and a slope of 2. Rising 2, running 1, rising 2, running 1. Remember, these are going by 1, 2, 3. I don't like this when, you know, these numbers are so small. They could have definitely gone by 1s here, but anyway. Okay, and then I care about this where it is greater than 0. And then here the y-intercept is 4. You guys see that? The y-intercept is 4. And so, and then the slope, and I care about it down here. So I kept looking on this side, and then I was like, none of those work. Then I realized that that's the one that does work. Okay, so you can start here and try to find the matching part, or you can start here and go this way. All right, you guys, we're gonna practice more piecewise functions. See you later.